I'm Jeff Fisher, an XR programmer at Epic for the past 6 years. And today I'd like to tell you about Unreal's transition to Openxr, particularly as it relates to Windows Mixed Reality and HoloLens. And first we'll introduce those three terms quickly. Unreal Engine 5 is the most open and advanced real-time 3D rendering tool, 3D creation tool. And I have a screenshot of the editor here because it's not just about the renderer and other runtime systems. It's about the tools and workflows that allow efficient creation of virtual environments. Next, we have Openxr. Openxr is a free and open standard for high-performance access to XR platforms and devices. Openxr reduces the amount of custom integration needed for an application or an engine to support multiple XR platforms. Simple function signatures and data structures, of course, but also the behavior of those functions is fit to the standard and identical across Openxr compliant platforms, identical within the standard. It doesn't have to be exactly identical, but there are limits to how it's supposed to behave. So we go from needing to implement a half dozen similar APIs to one. Much more of our code is shared across the platforms. This also means that this code is much better tested, not only in terms of the time spent. When we test against half a dozen different devices, we're testing that same code half a dozen times. But also we're testing that code across a greater diversity of devices, the exact timing, the exact settings of all those different devices. We're just sort of torturing our implementation better. Openxr has also been designed for cross and forward compatibility. The application requests information about device capabilities and can therefore operate on hardware that wasn't anticipated by the developers. Perhaps because it didn't exist, perhaps they just didn't test a particular hardware that exists. Of course, there's always a chance that something will go wrong with new hardware that was never tested, so you should try to test any hardware that you intend to use. But you have a good chance of it working on other hardware or needing minimal fixes for other hardware. Openxr is also extendable. It has built-in mechanisms for extending the API, adding support for new features. These could be unique to the platform, or they could be shared across multiple platforms. And finally, Windows Mixed Reality and HoloLens, Microsoft's set of devices, features, and APIs for virtual reality and augmented reality applications. Openxr and various extensions are now one of the APIs supported by Windows Mixed Reality. So we have Openxr, an API to be used in XR applications and implemented by XR platform holders. What's the structure of that at runtime? So there's three major elements. You have the application, in this case, an Unreal Engine-based application. This generates the virtual world a user will experience. Next, you have the Openxr runtime. This implements the Openxr API. So every function in the Openxr API will have an implementation in the runtime, exposing the features of the platform and the device to the application. And then finally, you have the device, perhaps an HMD and controllers. And this is the physical sensors and output hardware. The application and the runtime communicate through the Openxr API. So this slide presents this as if there's one of each, but there could be a number of each of these items. A PC workstation might have multiple Openxr runtimes installed, the Windows Mixed Reality one, Meta, Steam VR, and others. Let's look at how we're handling that. We'll start with the application. The application uses an Openxr loader to select the runtime that it should use. On a Windows desktop, the default loader just has a registry setting. So there's a registry setting that says which runtime is active. And if you try to connect to Openxr, you will connect to that one. It's possible to have different loaders. You can have custom loader instead of the default loader. HoloLens remoting works with a custom loader. You always have to make an explicit choice to use HoloLens remoting and tell it what device you're trying to connect to. So you can just use a special loader that will always connect to the right runtime for that. All right, so there could be different runtimes. There's a registry setting that says which one to use. This means that when you're working with Openxr, you need to be aware of which runtime is active. Because if you're intending to test one runtime and you accidentally run with a different runtime, it'll mostly work. They're both OpenXR, but certain features will not be working potentially. Usually what happens is there's a launcher or a portal app associated with the platform, and it will ask on startup to become the active OpenXR platform. Unreal will print the name of the runtime to the log. The VR preview windows from the editor will have the name of the runtime in the title of the window. There's third-party tools that you can use to see what your active runtime is right now and potentially also see, say, the list of extensions that it supports, which can be useful. So there could also be multiple devices. And it's generally up to the runtime which device it's used. If you had more than one XR device connected to your computer, perhaps this runtime only supports some of them, so it would choose those. Perhaps it supports multiple of them. Your application will send in some information about what kind of device it wants, so the runtime could use that to select a device. But regardless, the runtime chooses which device is exactly going to be used. And finally, there could be multiple applications. And in the case of the default loader, they would be asking a runtime for a second connection, and the runtime could just reject them, or possibly there are runtimes that support multiple concurrent connections. I haven't ever tried to use it on any of the runtimes, so I'm not sure if any of them actually support that. So we have an application which contains a loader, which finds the runtime. We communicate with the runtime through the API, and the runtime is operating the device. Let's talk about parts of the Openxr API. First, you have the core API. And this is what the Khronos group that developed the standard found to be essential or near enough to universal to make it the basic set of features for XR. With these features, you will have recognizable VR, device tracking, rendering, input, and the life cycle of connecting to the hardware. And the image here is a flowchart of the Openxr application lifecycle from the Openxr reference guide, one of Khronos' docs. And I find this very useful to just give me a high-level orientation to the different steps that you go through in an Openxr runtime. So if you want to kind of understand under the hood what we're driving, this document is a good place to start, and probably a good place to end if you aren't going to actually try to implement one of these, because the rest of the documentation is very long and very detailed and very critical to me, but probably not very important to someone who's creating applications through an engine. Next, we have Openxr Extensions. So extensions add new APIs to Openxr, new functions, new data types. During the connection to the runtime, you query the runtime to ask it what extensions it supports. And then you tell it what extensions from that list you want to use in your session. So some of these handle specific technical necessities that vary with platform. Whether you're using DirectX 12 rendering, Vulkan rendering, OpenGL rendering, you're going to have to pick one of these. But they may change over time and they vary by platform, so they're extensions rather than part of the core. And others add additional features like hand tracking, eye tracking, spatial anchors. A lot of the AR features are extensions. Hand tracking is a case where API standardization of Openxr was very nice. So here we have a picture of the standard hand skeleton from Openxr. The number, name, and orientation of the bones is standardized. And there was a fair bit of divergence in the various platform APIs as to exactly which bones they supported and whether they always gave you the bone information or not. And that was actually fairly hard to deal with on the application side. Not impossible, but annoying. And then finally, there's one more extension mechanism which isn't super relevant to app development, but there's something called Openxr API layers. API layers don't add new APIs, but they can monitor, alter, or consume API calls. And they do this in the loader. So before it even gets to the runtime, you could log out all the API calls that are happening. Or you could verify that the parameters are compliant to the Openxr spec and throw out warnings when they aren't. So that's a useful one, but all right, so we have Openxr and we have ways to extend it. How about the Unreal Engine? The Unreal Engine is also extensible. The mechanism we're going to talk about is plugins. So here are a few plugins related to OpenXR. A plugin adds executable modules to the Unreal Engine that will be loaded and run in the editor or an application. Specifically for OpenXR, we have an extension mechanism called an Openxr Extension plugin. Okay, now this is not like a subtype of the other plugin. This is any class that extends the Openxr Extension plugin interface. That interface supports working out whether the OpenXR extensions needed are available and has functions that can be overridden to do specific work, usually on meaning before or post meaning after an OpenXR API call. The ons would add data to that call, and the posts would read data out of the call. And here are a few plugins that one might enable for a HoloLens project. We've got the core OpenXR plugin, which gives you basically VR if you have that one enabled. We have OpenXR hand tracking, supports hand tracking, and we have the Microsoft OpenXR plugin, which supports a number of Windows mixed reality and HoloLens features. Let's go into more detail on how we do this support. So the core OpenXR APIs and certain critical extensions are supported in the OpenXR plugin. You'll always have that on when you're using OpenXR in Unreal, unless you've written your own OpenXR plugin. So usually what you would do is you would enable the OpenXR plugin and you would disable other XR plugins. Now you're going to use OpenXR for many or all of your platforms. And there's two modules within the OpenXR plugin. There's the OpenXR HMD, which handles the lifecycle of the connection, the frame sequence, tracking, swap chain management, view configuration, basic stuff for being in VR. Then there's the OpenXR input module, which does controller tracking, input, and haptics. Next, we have a few built-in OpenXR extension plugins. We have one for hand tracking, one for eye tracking, and one supporting a Microsoft extension that has hand tracking emulating a controller. You enable these if you want to use these features, but keep in mind that the OpenXR runtime and the device must support the feature for it to function. These extension plugins also serve as sample code for writing new extension plugins. And then we have one new extension plugin someone else wrote. This is the Microsoft OpenXR extension plugin. Adds support for a number of extensions, and you should go to one of their talks or listen to their docs mainly, but spatial mapping, scene understanding, HoloLens remoting, spatial anchors, the camera on the front of the device. They're supporting all of those things and more through their plugin. So with the ability to extend OpenXR via extensions and Unreal support for OpenXR via extension plugins, you can now add XR features into the Unreal Engine without us. It can be done often without changing the core engine at all. But it's possible that you might need a new OpenXR extension plugin function to override. And of course, with Unreal, you have the full source, so you can just add it to our OpenXR plugin. But if you want it to become part of the core engine so that you don't have to merge it with updates, a GitHub pull request is the ideal way to request one of those. So there's also elements of supporting an XR platform that are not XR specific and therefore are not covered by the OpenXR API and probably never will be. What if you had in your platform a user login system or some kind of store integration that could be put into an app? That's unlikely to become part of OpenXR, but you would still use a plugin in Unreal, like a non-XR service plugin, and you would be interacting with platform SDK, platform APIs, and like any other platform. So there's also what might be considered traditional platform support in Unreal. What that means is support for operating systems or architectures. So we have desktop Windows, which is kind of the default platform because the editor runs on it. And then we have target platforms like Android or HoloLens with either completely different operating systems or somewhat different operating systems like HoloLens, and with target architectures like ARM64. As kind of an aside, our HoloLens platform support is being refactored into what's called a platform extension, which separates its code better out of the core engine, making it more maintainable and making it so that you can turn it off when you're not using it. So in general, OpenXR is already the best way to use Windows Mixed Reality and HoloLens in Unreal. We are very near feature parity, and we are working on the OpenXR implementations a lot more and testing them more so they are better. There are a couple things still missing from OpenXR support versus the previous Windows Mixed Reality plugin. The Microsoft's spatial audio feature is not working in Unreal 5.0. And basically, we just need to refactor that to pull that code out of the Windows Mixed Reality plugin and put it into either its own plugin or the core engine. I can't remember which I'm doing. I'm doing this and I can't remember. Also, Azure Spatial Anchors is not working with HoloLens remoting, and that's on the runtime end. So the OpenXR runtime needs to have support for that. But it does work on device. So if you're starting a new project in Unreal for Windows Mixed Reality and you don't critically need one of those two things right now, you should probably start with an OpenXR project. I would recommend that you start with an OpenXR project. But if you have an existing project that you've been working on for a while, what are you gonna have to do then? Well, I had a test level that I made to test all of the Windows Mixed Reality features of the Windows Mixed Reality plugin. It's very old, and it had some lingering Windows Mixed Reality specific blueprints that had been superseded. Generally, they were superseded well before the OpenXR support, but they were still in my test level, and as long as I had that plugin, they continued to work, so I never fixed them all. So what did I have to do to make this test level work again? The first thing is I had to get the Microsoft OpenXR plugin. This is a test level that's all about Windows Mixed Reality and HoloLens, so most of the stuff it's testing is our specific features for this platform. In my case, because I'm working entirely from source and I needed the UE5 version a little bit early, I got it from GitHub. And I downloaded it from GitHub and I dropped it into my engine/plugins directory, and that was all I had to do. Now you could get it from the Unreal Marketplace if you wanted to, or you could get it from GitHub. Next, I disabled the Windows Mixed Reality plugin. So here I am, unchecking this box in the plugins dialog. And then I enabled all of these OpenXR related plugins that I wanted to use. The editor will want to be restarted at this point because it needs to, well, plugins are loaded or not at startup. So we're gonna have to restart the editor. And if you're building from source like I was, you probably also need to do a build. So I closed the editor, I did a build, and I reopened it, and now I'm back with all my new plugins. And here's what my test level looks like. I'm sorry that it's ugly, but this is it. All these little boxes, if you look at them and you do a pinch gesture, you'll test some kind of Windows Mixed Reality feature. But 3 of them are a different color, and they have the word bad in red text written on them. This is because these assets have failed to load correctly. So let's try to get some more details on what's wrong with these. So looking in the game log, and I'm sorry this text is a little bit small, but there were a number of red lines, errors, from the asset log, it says, in my log when my level loaded up. And if we look at these errors, we can see this one that I've cut here. There's 2, and they're both about the same thing. They say probable load ASA anchor from savegame.uasset. That's one of my little boxes. Class deleted without a redirect. So there's a class that it thinks was deleted. Well, that's probably a class that was in the Windows Mixed Reality plugin and now it's gone. And then set out AR pin and as a WMR AR pin. Okay, WMR AR pin. That sounds like that's probably Windows Mixed Reality. So that's probably the problem. And we know what blueprint to look at now, so we can open that up and we can look in that blueprint and we'll see some nodes that have error and red boxes and red text. WMR AR pin, it says right there. So this matches the errors above. So what do I need to do to fix this one? Well, so this is a cast node, so I'm trying to cast some object to a WMR AR pin. what do I really need? Over here, if I moused over on this in the live editor, it would say AR pin. It wants an AR pin. What is this object that's coming in here? Well, if I look at where that came from, it's actually an AR pin too. So I refactored this at some point to no longer use WMR AR pin, to always use AR pin. So I don't need to cast here at all. So I can just wire up around this node and delete it. And none of the things I had to correct were significantly worse than that. There were, across these 3 blueprints that didn't load, there were maybe 6 or so errors. So I can compile my blueprint, I don't get any errors. I could package my project and send it to a HoloLens device, or I could use remoting to attach to a HoloLens device and run my app. And everything looks good, and I look at a box and I do a tap gesture and nothing happens. No light up on the box. This is because my test level is using a very lazy input system. It's just a test level. I did the quickest thing, but that won't work with Openxr. So if we look in the pawn at where I was handling input, you can see Windows spatial input right tap gesture. That's a Windows mixed reality specific thing, and it's gone. This isn't an error because potentially if you're deploying to different target platforms, specific button presses might not be valid. So it's a warning instead of an error. And it probably did appear in the log, but I didn't notice it. And you can see that I had some kind of a touch input for a handheld device wired up here too. So I was using this is gone. I don't have a way to trigger the rest of this blueprint right now. But also Openxr, when you're getting input through Openxr, you can't just wire it directly to buttons anymore. And we'll go into some background of how Openxr input works to explain why that is. So Openxr input is action-based. An action is an input for your application. I want to make a select. I'm going to make a gesture and I want that to select. Or if I was using a controller, I would hit some button and I want that to select something. You could also make an action for jump. And then you want that to be associated with particular physical hardware, right? But remember, Openxr is trying to enable cross-compatibility and forward compatibility. So if I'm just binding everything to specific hardware, it's not going to work. But there has to be some level of indirection there that where we can close that gap between the future hardware and what I know now. The way Openxr does this is it has some descriptions of physical hardware called interaction profiles. And over here on the right, I have one of the interaction profiles, the definition of it. Interaction profile, Microsoft motion controller. So this is the definition of a Windows mixed reality controller. It has 2 user paths, one for the right hand, one for the left hand, or the reverse. And then it has all these component paths, which are specific buttons and a haptic vibration feature. And these are on top of those user paths. So there's a trigger for the left and the right. There's a thumbstick for the left and the right. All these different specific inputs, right? So this is an interaction profile. It's a description of hardware that is being supported right now. So I'm going to bind my action to some of these paths, whichever ones I think are appropriate. In my case, I bound it to the trigger on the mixed reality controller. So on a Windows mixed reality controller, either trigger will be the select action. But I also want this to work for HoloLens. HoloLens doesn't use controllers, it uses gestures. But we have that extension where hand tracking emulates a controller and the tap gesture is called select or something like that in that one. Unfortunately, it's cut off in the picture. But I bound those, the left and the right tap gesture, to my select. And then what will happen is when we're starting up our Openxr, we're going to say, Openxr, I'm going to suggest that this action, select, could be bound to all 4 of these things. And the Openxr runtime will look at my suggestions and pull out the interaction profile for them and then choose one of the interaction profiles to use, whichever one it best matches the hardware. Assuming it supports any of these, right? So I would expect on a HoloLens, it will pick the hand interaction profile because it's doing hand tracking, and this thing was specifically made for it to emulate controllers. So hopefully it will check that. It will choose that one. And on a Windows mixed reality control device with stick type controller, I would expect it to choose the trigger on that controller. And if it is exactly a Windows mixed reality controller, that's going to be exactly the trigger I expected. But maybe there's some future device that has 2 triggers, and it'll choose whichever one is kind of the primary trigger, maybe. So that's how we get that the runtime chooses from the different interaction profiles that you suggested which ones it supports. So if I'm thinking about getting a lot of cross-compatibility or a lot of forward compatibility, it would be a good idea for me to support quite a few interaction profiles, especially the most famous ones. And in Unreal, we have an action mapping. We make an action. We add some of these keys, which represent specific paths, and then we're good to go. And we fire up our application, and now the pinch gesture works. And if I try it with a Windows mixed reality controllers, the triggers will work. Another thing that's important to understand here is that the runtime will choose one of the interaction profiles. So you need to make sure that every interaction profile has all of the critical inputs for your application. If you're missing one, then your application is now broken because there's some critical thing that the users can't do. So make sure you're careful about that and test your interaction profiles that you're going to use. So OpenXR in Unreal 5 provides benefits for both cross-platform and single-platform projects. For cross-platform, you get better compatibility because the farther down we go and make everything the same, the fewer differences are going to disturb us when we're trying to pretend like all these devices are exactly the same. And also, we're getting better testing of that integration layer. And then we're also potentially having the capability of running on future hardware and behaving better than we would have otherwise. For single platform development, there's also some really big advantages which are not quite as obvious. Because platform holders can design a new Openxr extension and then submit it to Khronos and implement it in their runtime and make an Openxr extension plugin for Unreal, they can add whole new features to XR potentially without even telling me, right? They can just add it all in all by themselves. And if they have to, they can change the core engine because you can do that with Unreal, but a lot of the time they won't have to. And that means they can do everything faster. So what are we going to do if we don't have to do as much platform integration work? We have a lot of features for Unreal 5 that we would like to connect up to XR. There's an enhanced input system for Unreal that is action-based, so it's a better match for OpenXR. I don't know if you noticed when I was explaining how to do input right now, you have keys that map to paths. It's a little bit weird there, and the code that does that is horrible. There's a giant set of ifs that mangle keys into paths. We'll be able to do better than that. And it supports things like switching the set of actions that is active, which OpenXR does support too. We also have a lot of rendering features. We're going to be trying to look into which of those can work with stereo rendering. And we also have just workflow improvements and sample projects. We are working on making more sample projects, and that allows us to find workflow improvements to make developers more effective. One that I've been working on recently has to do with multiplayer VR. So if you're working on multiplayer VR, one of the irritations is that on a single workstation, you only usually have one headset. And if you have 4 players, right now the headset is always the first player. But it would be cool if you could make the third player be the one with the headset. You could test some things a lot faster than having to have another computer to connect in to be the third player. All right, so if anyone has any questions. Okay, so let's go back to. Yeah. So the loader here is part of your application. So that's going to be running in your process space. The Openxr runtime is potentially not all in yours, I think. Like the first layer of it, you're getting function pointers and you're calling into those. But I guess I'm not entirely sure. Like, it definitely can have its own processes controlling the device. A lot of times the low-level control of the device is a completely separate process so that it isn't, so that they can get better, harder real-time performance out of that. So I'm expecting that there's a layer somewhere in there inside of the runtime. Yeah. The loader is part of the Unreal application, or a part of the application. And really, if the loader isn't doing any API layer stuff, it can just give you the pointers that go directly to the runtime. And then the loader isn't really doing anything. It just does something at the startup. You say, give me the pointers to all the API functions. And it could be passing you direct access to the runtime. Or it could be passing you its own layer that happens before the runtime call, right? So it could go through a number of steps inside the loader and then go to the runtime. But it could also just be giving you directly to the runtime. And you don't really know unless you are paying close attention to the loader.
I can generate the loader?
The loader is part of the Openxr plugin of Unreal. It's being referenced by the Openxr plugin. So our core Openxr plugin has the loader. The Microsoft Openxr plugin has the custom loader that they use for remoting. For desktop, it uses the default loader, which is in Unreal's core Openxr plugin. That's where, yeah, your application would decide which loader you're using. And then your loader decides which runtime you're using, right? The loader is actually pretty interesting. I hadn't read a lot about it until pretty recently, and the Openxr documents on it are interesting, all the different things you can do in the loader. I mostly paid more attention to the runtimes. So a lot of the runtimes, when they were initially implemented, were just a layer on top of the pre-existing platform runtime, right? So they just kind of aliased everything. And then as time goes on, they'll dig deeper and replace things to get to make it more direct, cut out overhead. On the the blueprints? Yeah, I mean, if you have full source and access to all of the C++, so you could do everything in C++ if you wanted to. Generally, we think that it's faster workflow to use the blueprint level features for most things. But if you need to, you can always go deeper and get more direct access. I mean, we're making all the Openxr calls directly in C++, so you can make all of those directly yourself if you want to, or you can write your own plugins to expose things to Blueprint yourself if you wanted them to be exposed differently, but to still use those tools.
Do you provide
The Microsoft's, yeah, well, okay, so the special loader that we talked about is only for remoting to HoloLens. We use the default loader for desktop Windows VR or XR. We have support for, so we have the core API and the critical extensions like the rendering ones in our core plugin. And then we made several extension plugins. One of them is for a Microsoft extension, the hand interaction where you simulate controllers with your hands. But most of the features are in Microsoft's Openxr plugin. So they implemented those and they can update them with their runtime faster than the engine updates if they want to. Yeah, we have documentation of the features that we support, and they have documentation of what's in their plugin. So, yeah, they have very extensive documentation of those features. They are generally, I would say almost all of the features that were part of the Windows Mixed Reality plugin are part of Microsoft's Openxr plugin. The only exception might be the gesture support is, I think, kind of more of the Mixed Reality Toolkit plugins rather than the Openxr plugin. But mostly it's yeah, almost everything is in there. Like everybody's ready to go. Oh, there you go. Yeah, so the question is about what rendering features we are going to support for Openxr and the status of that in Unreal 5. It's not really that they're not supported in Openxr as much as it's that they're not supported in stereo rendering. And we are investigating which of those features can be supported in stereo and whether they can be supported at the frame rates necessary and on the devices necessary. There are definitely limitations with mobile-based platforms. So yeah.
Can you guess how?
Yeah, I mean, I'm not the best person to ask that about, but some of it is that there are optimizations for doing stereo. You've got two views that are very similar, right? And you can make some optimizations by saying, aha, we're just going to assume that these two eyes are the same for these purposes and the results are good enough. And that tends to be invasive into the rendering pipeline. And some of it is just that it hasn't been done, and some of it is that the performance wins might not exist. And for one of those things is clearly worse than the other, right? But we're going to see what we can do. We do not have a specific schedule for these things. Yeah. Okay, that may be. Oh, well, we're working on the samples, so they aren't cool enough to show yet. I showed you guys my super ugly test level, but that might be all that you get today. Yeah, more coming on samples. Probably in the, we're working on them right now. So.